inequalities. We've already looked at inequalities as far as just in general themselves. Now, we're going to start to look a little bit, hey, what happens when arrows get thrown into our equation lives? And what does this look like? So, here's the first thing that we're going to do. This is going to seem strange. Up here on the top, we are not going to use dots. The reason for this is, as you move along in math, it's going to go away from dots and more towards these two symbols that I'm going to show you here. So, if you are going to have less than or equal to, greater than or equal to, we are going to use, okay, a bracket, a brace. And I'll show you that when we get into the graphing part here in a sec. And then, if it's just less than or greater than, so no line underneath, that is we are going to use a parenthesis for that. And the reason for that is when we get into the second part of this, which is what's called interval notation. And that's going to help us see if something is included in our answer or if it's not. And so on these first couple of examples that we see here, we're going to graph the inequality and write the solution in interval notation. Okay, first things first when we start the graphing game here. Normally, I like to put the number I see in the middle and then at least a couple of numbers around the outside edge. At least one to make sure that we get our notation set with stuff. What can I help out with?
What is that?
The notes. The notes haven't changed. The notes aren't new.
Oh.
Yeah, the notes aren't new. Just the practice packet here. And everything else we're still rolling. But I still have extra note packets if people ever need them too. So we can sit there. So what we're going to do with our interval notation here is x is greater than 8. You're like, okay, wait a minute. So if the arrow is eating x, or if it has the line under, doesn't matter which one, that's greater than. It means the numbers are getting larger. So when you're on a number line and the numbers are getting larger, our arrow's going to go to the right because as I go to the right, 8, 9, 10, 11, they're getting bigger. I'm also going to use a symbol to let whoever looks at this know if 8's included in my answer or not. So here, the 8 is going to get a bracket because we use brackets whenever it's or equal to show if 8's included in our answer or not. So greater than to the right, bracket to show the or equal to part. And so the last piece is a thing called interval notation. So when we do interval notation, we're going to look at our graph and we're going to write on here what's going from left to right. So I'm looking at my graph like, okay, where does it start? Where's its beginning point? Well, its beginning point's right here at 8 with that bracket. So I'm going to start with a bracket, and I'm going to start with 8. And then as I go to the right, it doesn't stop. It just keeps going and going and going forever. And we signify forever with infinity. Positive infinity in this case, because my numbers are getting bigger and bigger forever. And infinity will always be a parenthesis. Actually, we're going to write that in here. Infinity. Actually, we'll put both. Negative infinity and infinity are always parentheses because they don't have an end. I can't include infinity because, well, you can't do that. You can't put your finger on the end. It always gets away from it. But that's all we're trying to do here with these. And so if I have less than, Like, wait, how's this less than? Because in this case, if the arrow's pointing at the variable, that's what less than is. You are less than me, A, kind of pointing at it. X is getting eaten by the arrow, greater than. A is being pointed at, that it's less than. So less than goes left. So I jot me some numbers on my graph here again. And I go to -1. I'm like, okay, here I am. It's just plain old less than. So we're going to use a parenthesis. So less than is left. Get our parenthesis in there. So A is less than -1. Because the more you get negative, the less value that you have. Hey, hey.
Hey, Mr. Hardy, might interrupt real quick.
Sure.
A very special announcement for this class. We have a Husky of the Week in our presence right now. So this student has been participatory and has a positive attitude in class. Where's Tice?
All right. So my interval. One last part to this. Remember, we're going left to right. Well, this time my left. Where is it? Oh, it's still going. It's still going because it's going forever to the left because I'm following the arrow to -infinity because it never ends. And then as we come to the right, we keep going to the right. We run into our end here, this parenthesis, at -1. And we're done. So I gotta keep stressing the left to right thing. If you're a person who uses colors or a highlighter, I'd highlight, star it, do something like that to make sure that we keep our direction straight. So we gotta do it left to right. So how do I use that to actually solve something? Let's see. So I'm not gonna talk about the special case until we see it because that could be distracting. So solve, graph, and write the solution in interval notation. Okay, first issue. I got to get all my V's on one side. I would suggest that when you're doing this, you get all your V's on the left. It's going to be easier to know what direction your arrow is going to go when you go to graph it. So if we do that, they're on different sides of this arrow. This arrow is like an equal sign. It's kind of like a wall here. So we've got to do opposites to move things when they're on opposite sides of the wall. So here, the V's are gone on the right side. So goal number 1, bless you, all of our variables together. Good. Next issue. Now that all of our V's are together, we need to isolate it. We need to get it all the way down to V. So, first goal, get -2V alone. How do I get the +1 out of there? Minus it. Oh, we're about to hit the special case. Okay. Finally, we're almost there. We're multiplying V by -2 to get it alone. What's my last step to undo multiply? Divide. So here's the thing. We're going to star this because we're about to do the special case up here. Normal rules to solve an inequality, but you have to flip the inequality symbol if you multiply or divide. I'm going to put a little note under here too. Both sides by a negative number, which is exactly what we're doing right here. To get V alone, I had to divide both sides by -2. So when I write my answer, that arrow right there is going to flip. And I get to my solution. I don't want to add to. We got to watch for things like that. That's something we saw in the first quiz. And so I get to this, and I go, okay. So let's see here. So 9, 8, 7, get some other numbers in here. 2 questions on every graph that you ever do. First question, Is my symbol on 9 going to be a parenthesis or a bracket? Is the plain old less than a parenthesis or a bracket? Parenthesis. So we got a parenthesis, and if our variable is on the left, we can follow the arrow. That's less than, it's pointing at V. Less than goes left. I got my graph done. And so now my interval again, left to right. If the direction you're starting with is an arrow, that's an infinity. Negative infinity this time, because it's going left forever. Until I get over to the right. And I use the same symbol I used on my number. That's it. Nothing fancy. Nothing fancy at all. So I'm just trying to see. I'm looking at one thing quick. Okay. So here's what I want. Do I want to try that on this one? No, I'm going to save that one for 5. We're just going to be playing on this front part, I think, today. So here I look. One more, and then I'm going to kind of mix it up. I'm going to have you all try one. We're going to see how this goes. Here, whenever we see parentheses, distributing's got to come first. So what do I do with the 21x? Nothing. Nothing at all. Negative 3 times 5. It's negative 15. Negative 3 times 9 is negative 27. And seriously, do not feel bad if you're getting the steps down, but you need the calculator to check something when you're multiplying, dividing, adding, subtracting. Do it. Okay, it's not a bad thing. The reason I wanted to do this one was for one reason. On the first one, my v's were on opposite sides. I did opposites. This time, my x's, they're on the same side. Don't do opposites. Just put them together. They're like terms. So 21 minus 15 is 6. I don't even have to move x's from one side to the other. They're already on one side together already. So now I keep rolling, and I'm like, all right, gotta get the x's by themselves. How do I undo the minus 27? Gotta add that. Oh, I think decimal world or fraction world is coming here. Ugh. All right, one step to go. We're multiplying x by 6. We're going to divide. No flippage this time. No flippage. We're not multiplying or dividing by a negative, but we are going to get something decimally. Let's see here. All right, if we go decimally, let's just go to the nearest tenth here. So we'll call this 5.7. I don't want to get into the crazy fractions with you. So you're like, okay, 5.7, what the heck do I put on the lines around it? Think of it almost like it's 57 with a decimal. So 5.8, 5.9. So it's like we're in the 50s. We're just doing it with decimals. 5.7 still the magic number place to be. There's my inequality arrow. What symbol are we using on 5.7? Bracket. And which way is my arrow going? Oh, I hear opposites. X is greater than 5.7. Which way are we going? To the right. With a bracket. So we get here, we're like, okay, left to right. This time, my 5.7 is the left. And off we go, and wherever we go to arrows, we have infinities. Okay, here's what we're going to do. For people watching this later, pause me. You can't pause me live, though, so sorry. I'm going to freeze frame this for a minute. I want you to try out number 5. Using those first 2 kind of to help. Just the best you can. I'm going to quickly do mine on here, but I'm going to be around to help out if there's some places you're getting stuck, because I want to make sure that after we get this first day worth here, that we're heading a good direction. I'll be right out there. I'll warn you, you're going to get a decimal. You're going to get a decimal. Come on, Hardy. Okay. Rolling. So here's the 2 things I've seen. The distributing, we've got that good. The only thing is if we have negative times negative, that's going to be a positive. So that 4p is going to be plus. The only other thing I saw regularly out there that just was a tiny thing is, and I see why you would do it. Some of you got to this last step and you're like, hey, I see a negative with the 60, so it must mean that I flipped the arrow. But the only time you flip the arrow is if what you're dividing or multiplying both sides by is the negative. Not just because you see any negative. This 8 is positive, so we got to make sure that we just leave that alone. And other than that, what I saw was good stuff. Between this and greater than going to the right, and right meaning we're going to have positive infinity, which is absolutely excellent, especially for day 1 of this. This is why we hang out in these things for a few days as we go. I'm just checking one thing here quick. Okay, one last example to play with. I just want to see if I want to change things up. I do not. Do I want to change it up on there? I do not. Okay. So last one to be sure on here. If there's even just a minus in front of parentheses, we're going to distribute that through. So this is, this is going to become negative for it. This is going to become negative 1. And we're going to have a little extra to do this time. Because this time, kind of like we did in number 4, same side of the equals, I have like terms. So I'm going to pause for just a moment, not freezing the screen. But we're going to combine those like terms. No opposites, because they're on the same side. But then, once I'm here, now again, I want to get all my m's to one side, like we did in number 3, like we did in number 5. I like keeping them on the left. Okay, always about those quick little opposites that we're doing. Again, if colors help, I've got my box up here. I don't know why I haven't put them in the back yet. This is a positive 2 that I'm adding to negative 9m. So the opposite of that positive 2 would be to minus 2 to each side. It does get a little methodical here. I get that. Okay. Moment of truth. We're multiplying both sides by negative 9. Okay, got to get my m alone. Dividing by negative 9 to both sides. Do I flip the arrow or not? Yeah. We've got to flip the arrow because we divided by a negative. So I finally get m by itself and I get that solved. So let me get my values in there. Make myself a quick note there. And again, if your variable is on the left, you can follow the arrow. The arrow's pointing at m, it's less than. Less than goes left. Here, talk to me. I'll come back in a minute. Or equal to, we've got a bracket. And when we go to do the interval, left to right, arrow going to the left, to negative infinity, to right, and use the symbol that's there. Okay. Like I said, we're going to take our sweet time through this. So, here's what we're going to do as far as practice goes for now with what we've dealt with. So, in your new practice packet, on that very first page, right, whoop, a little too high, Hardy, right here, we're going to hand pick some problems out here. So, here's what we're going to do. We are going to do 1 through 4, 6 and 7 for right now. Okay? 6 problems. We're trying not to go over crazy here on day 1. If you want the extra challenge in dealing with number 5 or number 8 with the fractions, go for it. I got the answer on the key, so you can check. But at a minimum for today, 1 through 4, 6 and 7. Check things. Even if you're not sure, go as far as you can. And if it's not matching, ask a neighbor, ask me. Let's keep the communication going to make the